This conference will now be recorded.
Hello, everyone. Good evening. We'll wait for a few more minutes and get started. Can you all hear me?
Yes, Karan, we can hear you.
Okay, thank you. And also see my screen.
Yes, I'm able to see.
Okay. Hey, hello. Can you all hear me?
Yes, Kiran, I'm able to hear you.
Thank you. All right. So just a little, recap of the demo for those who might not have attended. My name is Kiran, and I have about 13 years of experience in IT, and out of which 8 9 years is in DevOps. And I worked on both AWS and Azure, and also I have worked on, extensively working on Kubernetes and setting up CI/CD and infrastructure as code and stuff like that. Okay, so without going into all the details, I would like to just give you a brief overview of what we are going to learn in this course. So this is briefly what we are going to learn. Apart from that, there are some theoretical concepts that I'm going to talk about, mostly in the first few weeks, first few days, in fact. Okay, right? And also, we will talk about some interview tips. Whenever I discuss some topic, I don't have a list of topics or list of questions, and I don't think that's a good approach too. But generally, I can tell you what kind of questions do come up in interview based on the level of experience you put in your resume. So I'll talk about that, and I share some notes and I'll share some, documents through my GitHub. You can go through them. I will talk about some resume tips, how to write your resume and stuff like that. But don't ask me to review individual resumes. That might not be possible. And like I said, I will also talk about how to use Chat GPT for uh, you know, how do we use it in a day-to-day life of a DevOps engineer. Okay. So if you're not speaking, I would request you to go on mute. Bharat, do you have a question? Yeah, thank you. Okay, so what do you need to have, what do you need to be in this course, whatever. Okay, so you need a computer, obviously a laptop or a desktop, doesn't matter, with administrator rights, because you will have to install some software. If you have a work only laptop, you have to tread with caution. Maybe, I don't know, these are all like open source softwares and no licenses, but I don't know what controls your organization has. And regarding the subscriptions, you have to have an Azure free tier subscription. Don't create it now, because we will create it start of next week, because it's only for 1 month, and the first 1 week we are going to discuss some basic concepts, and then I will tell you when to create it. Okay, and you also need a backup Azure free tier account. When I say backup, that's because Azure free tier is applicable for only 1 month. After 1 month, you can either convert into pay as you go, which means you will pay for the amount of resources you use, or take your friend's help or someone, your brothers or whoever's help, and create a secondary account. Why can't you create a secondary account yourself? Because Azure has some algorithm in the background which will detect if you're creating a secondary free account from the same IP address or from the same laptop. Because mm, even if you're using a different credit card and a different email address, it might still not work. Okay, so you have to go to your friend's laptop, go to your friend's place or somewhere, and create it on your friend's laptop, because it can recognize both your MAC ID and also IP address. So I would say that, but that's after 1 month. You don't have to worry about now. But you would need a credit card to create an Azure free tier account, and I will talk about that in step by step manner how to create it. Don't worry about that. And you can create a GitHub account already. You can, if you want, you can create it today itself. It's free. You don't need any credit card or anything to sign up. And a Docker Hub account, which is where we put our container images. That's also later in our course, but again, no harm in creating today itself. Okay, you need to install some software on your laptops. You need to install Git. You can do it right away today or later. I'll explain to you that. Okay, Azure CLI will also come later. Don't worry about that. Terraform, Docker, and VS Code. These are the tools you would need on your laptop. All of them are free, and you don't have to pay anything for that. Okay, personally, again, I put this question, put this point, because people ask me, do I need to know already how to code or how to write programming? How to write programs? It's not required, but if you know, that's awesome. But if you don't know, you will have to, I'm going to teach you like shell scripting. I'm going to teach you how to write YAML scripts and various other scripts like Terraform. So you will learn them through the course. But yes, we will do a lot of coding. We will deal with a lot of code. Okay, initial days, yes, we are going to do it through uh, Azure portal and all that stuff. But going forward, we will do a lot of commands and we will write a lot of code. So that's pretty much what you need. Okay, so again, before I dive into today's topics, you have any questions, or based on whatever I said so far?
Hi Kiran, this is Bharat.
Yep.
I actually have a general question. So, how long this course last for?
Yeah, this might take about 9 to 10 weeks. Yeah, I mean, I would say about 50, 55 sessions approximately, for all the topics needed. Okay, but yeah, I would say 2.5 months for sure, because we are doing only Monday through Friday, unless there is some, unless we are falling behind in schedule, there will be no classes on Saturday, but maybe 1 or 2 Saturdays we might have classes. Saturday and Sunday also no
So,
classes, only Monday through Friday.
are you taking only one class each day?
Sorry?
Are you taking only
Yeah,
one
yeah.
class?
One class, 1 hour, 1 hour, 15 minutes. I mean,
All good.
I can go on for longer, but you'll lose your focus. But you have
Yeah.
to again spend some time on practicing as well.
Okay, all good.
Yep. Okay. Any other questions? Okay. So I will also talk a bit about my approach, how I take the classes, okay, and all that stuff, so that you also get an idea. So basically, my class will be mostly hands-on. Okay, it's less about PPTs and more about showing you stuff how to do. Okay, so my choice of tools is pretty simple. I use like two web browsers, Chrome for the call. I don't know, Firefox doesn't work with GoToMeeting. And I use I primarily use this tool called as draw.io, or appdiagrams.net. They have different names, where I draw diagrams and try to explain to you the concepts. Okay. So I will use this, and I generally, whenever I have to, mention something, I generally write in a notepad so that you can see that and understand. Okay. Um, I write the notes here. I mean, this is not to share with you, but anything that needs a little explanation, or I need to write down and not draw, I use a notepad. Okay, and yeah, pretty much that. And we have GoToMeeting. I use a Linux machine, not a Windows machine, so the interface might be slightly different, but you don't worry, you will also have a similar tooling on your laptop. Yeah. So try to use, you also can use some notepad to make notes while I'm speaking, or you can use a physical notebook and text pen, like the good old school, whatever you like. Okay. Yeah, pretty much that. So I go through different windows, but I do explain which window I'm opening. Okay. And pretty much less of PowerPoints and more of hands-on is my approach. Okay, so today I would like to talk about very simple topic. Okay, we will talk about introduction to um, IT infrastructure in a different way. We will go from end user to the deep down. Okay, so before I start, any other questions?
Yeah, do you need Linux or Windows?
No, no, you don't need Linux for Windows, but we are going to learn a lot of Linux. So what you can do is you can install Git. Okay, Git is a software which is used, I mean, which we will learn also how to use Git. So Git is a software that is used for version controlling. But when you install Git for Windows, it comes with a tool called as Git Bash. Okay, Bash is nothing but the shell used in Linux. Okay, uh, so you can actually use this Git Bash tool. The tool name itself is Git Bash. You will get this once you install um, Git tool. Okay, this is the URL. I can paste it already here. Okay, but if you're enthusiastic, you want to, and the way we practice Linux is we will create an Azure virtual machine, and you will connect to the Azure virtual machine through Git Bash command line tool. I mean, Git Bash just looks like this tool, okay? A command line tool, that's it. So through Git Bash, you will connect to Azure virtual machines, okay? And you can practice Linux commands there. But if you are enthusiastic, if you want to learn Linux without even Azure virtual machine, of course, you will need Azure virtual machines to practice other stuff. But there's a wonderful option which makes Windows less uglier. It's called as Windows Subsystem for Linux. Okay, so or WSL. You install this, you have a Ubuntu machine on your Windows laptop itself. It's like a virtual machine. So you have a command line like this. You can practice Linux commands on your Windows laptops itself. And trust me, that's a good way to do it. Okay. For example, I know some of my friends who are working in organizations where they give only Windows machines. They all install Windows subsystem for Linux. Okay, which means it's like a Linux virtual machine on your Windows PC. Okay, if you have your personal laptop, I would recommend to try this out, and it will make your life easier. Okay, all right. Yeah, you don't need Linux as such. It would be wonderful, but you should not worry if you don't have.
Thanks.
Right.
Thanks.
Yeah, no problem. Okay, so any other questions? All right, then I'll proceed with my first question to you all. Okay, so you open your laptop and you want to search for something, and you go to your favorite browser like Chrome or Firefox or Edge. Okay, and you type in your address here. Like let's say this is Chrome, and you type in google.com, right? So what happens next? And this is a famous interview question. I mean, I don't want you to go into that depth, but software engineers and also DevOps engineers are asked this question in so many interviews. Okay, we don't want to go that deep because we're just starting, but tell me what happens when you type in google.com.
It sends a request to the server and you'll get the response from the server.
Okay, so you say it send who sends the request? My browser, okay, to the server. But how does it know where my server, where the server is, google.com server is? I mean, the easiest answer is computers have to know that, right? They have to figure it out. But there should be a way to figure it out, right? How do they figure out?
Based on the IP address of the
Okay, so IP address. But who has the IP address?
The
Where is
website has
this
particular
located?
domain, right?
Okay, so what is a domain?
DNS.
Okay, so there are a lot of names coming up, so I will pull up my notepad. So we have IP address. Okay, for those who might not be very familiar, don't worry, I'll explain to you all this. So we have DNS, we have IP address, but where is my DNS located? Where is my how is my IP address, or how is the IP address of Google known to my laptop, my browser? Okay, so we'll come to the server part later, little later, today only, don't worry. But think about this. When you are connected to internet, what device you are connecting through? What is the device you are connecting? Using which device are you connecting to the internet? In your home, we all have it on our homes.
routers.
Routers, right? So the first request your computer sends to is not a Google web server, but your router. I mean, not only your computer, even if it's a phone or your smart TV, right? Your phone or smart TV, everything sends their request to even your smart fridges or your Alexa, everything sends their request to the router, right? And your router, where is the next hop? Where does the router send the request to? Anyone?
Server.
So,
Provider.
Server.
okay, so
ISP.
It's internet service
ISP.
provider.
Yes, brilliant. ISP. So we all have an internet service provider to which we subscribe, right? I mean, we take a connection from our internet service provider. It could be, Act, it could be Airtel, it could be Geo, it could be, mm, you know, what else we have? BSNL still has ISP. Yes, it does. So the next hop is internet service provider. Okay, let's suppose you got a brand new laptop, brand new internet connection. Okay, no one has ever connected to google.com from this laptop or in your home address. So the first thing your browser does is, it checks in the browser cache. Okay, the word is cache, or cache as some people pronounce it, cache. So the browser checks in the local system if it has the IP address. If not, it sends the request to router. Okay, so routers also, most modern routers also use the caching mechanism, meaning they can store the DNS entries. Okay, what is the DNS name? I'll come to that. Let's suppose your router is also brand new connection. It doesn't know any information. It will send the request to internet service provider. Okay, internet service provider has something called as a DNS resolver. Okay, it's called DNS resolver. Don't worry what that is. It's kind of a service that is installed on the servers, which will help you to find the IP address of the domain name. Okay, domain name is nothing but the name of the website you are looking for. Okay, so let's suppose your ISP also doesn't know it. Then where does the request go? Okay, the request actually goes to what we call it as a root server, DNS server. Okay, I mean, again, this is part of your DNS. Okay, we are not even talking about going to Google servers. Before going to Google servers, you have to find your IP address. Okay, root servers. So what is DNS? What does DNS stand for?
Domain name server.
Yeah, but it runs on multiple services. So let's change the name to domain name service. Okay, what's a domain name service? It's a service that helps you to find the IP addresses of all the domains. Okay, IP address. So you give it a domain name like google.com and it gives you an IP address. Okay, it's a simple, table of domain names and IP addresses, just like the good old telephone directories. Okay, in the 90s, we had something called as telephone directories because we did not have smartphones back then. So you have to either write them manually in a notepad, notebook, or you have this directory published by Yellow Pages or whoever it is, and you can open it and see it. But this DNS service is a digital service. It's available online. Okay, or let's suppose when you're dialing on your phone, also in your mobile smartphone, also you just pick up the name, but what happens in the background? You have a name, phone number attached to that particular name, and it dials that name, right? So similarly, computers don't understand English. They understand only numbers, zeros and ones to be particular. Okay, so uh, they need the IP address to be able to communicate to the target server. Okay, so what happens is your request goes to a root server which has the list of all the top level domains. What is a top level domain? For example, .com is a top level domain. So if you take a website name like, let's say drive.google.com. Okay, just giving an example of a website name or a URL. Okay, so here google.com is the domain name, drive is the subdomain, .com is what we call as a top level domain. Okay, level domain. But today we have a lot of top level domains, not only .com. We have like .co.uk, that was there from a long time, .au, .com, sorry, .com.au. These are country specifics. We have .co.in. We also have .in. We have .org, .edu for educational institutions, and .info, .me, .website, you name it. You have a lot of top level domains these days. Once upon a time, these were like 5, 6, or maybe 10, 15, but you have a lot of top level domains. Anyway, so this root server has the information about all these top level domains. Okay, and let's say because we are searching, or we are trying to open google.com, when the request is sent to root server, it sends the request to a top level domain called, okay, the .com servers. sends the request to .com. Okay, this is called TLD server. This is part of your DNS resolution only, meaning finding the IP address. You're not even going to the Google service. Then the TLD, but this is important for us to understand as DevOps engineers. Okay, and the TLD will send the request to what is known as a registrar. What is a registrar? Anyone knows? Okay.
We can buy the domains.
Yes, exactly. So
Yeah.
we can buy the domain names. Why is it important to buy the domain name, right? Because can I start a, because I can create multiple servers or 2 servers or 3 servers on Azure, and I can start running some application and make it as a public application. Can I name it as google.com? No, right? Why can't I name it? Because google.com has been registered to Google LLC a long time ago, right? Or I cannot use wikipedia.org also, or wikipedia.com also for that matter, because it is registered to Wikipedia company or Wikipedia Foundation, Wikimedia Foundation a long time ago. You cannot do it. So we all have to, I mean, if you want to start an online service or whatever service it is, if you want to have a website, you need to buy a domain name. Okay, you're buying a domain name, not a server or nothing. You're just buying the name. Okay, let's suppose I want to start a website like devopsgym.com. Okay, so I go to a registrar. Registrar is a person who can help you, or who sells the domain names. So there are a lot of registrars. One of them common is like GoDaddy. Okay, you have domains.google.com now. Sorry, google.domains, I guess, where you can buy domain names from there. You have Namecheap. Okay, you have AWS Route 53. You have Cloudflare. So you can buy from any of these registrars, but all of them, okay, will actually report to a body called as ICANN. Okay, um, this is called as Internet Corporation for Associated Names and Numbers, or Assigned Names and Numbers, or something. I mean, you don't have to by heart or remember this. There are 2 organizations which centrally manage all the top level domains and all that stuff. Okay, so it's like this. Let's say you buy a vehicle in Vijayawada, and someone else buys a vehicle in um, Gunturu. They register their numbers in a different what do you call districts, but still both of them, there is no chance of their numbers being overlapped, because there is a central register, central transport authority, which will have all the names, so no one's name can be duplicated, right? No one's vehicle number is duplicated. Similarly, if I bought devopsgym.com, no one else can buy devopsgym.com unless they ask me and they take it, or my subscription is elapsed, or I stopped paying for this website. Okay, so devopsgym.com, for example, if I bought it, no one else can buy it because it's registered in with these organizations, and any of the registrars, they will not allow you to buy this website again. Okay, so I also have this really registered to my name. I'll show that to you later when we talk about Azure DNS, how to how you can associate an IP address to this domain name and all that. I'll show that to you. But right now, the point is, um, your request goes to the registrar, and the registrar will give the top level domain the IP address. Okay, and all these places, there is something called as caching that happens, meaning when the registrar answers with the IP address, the top level domain.com will save it. Okay, and let's say your root server, it will also cache it. Okay, and also it will send to your ISP in the sense it will send to your DNS resolver. It will also cache there, and it will send it to your router. Router will also cache it. Your laptop will cache it. So what happens when the router caches it? Someone in the same household opens their mobile phone and type in google.com. Now your browser doesn't have to go through all these paths and get the IP address. It simply gets from your router. Okay, because it's already cached here. And of course, another thing to remember is, I mean, it's again when you're changing IP addresses, it might come into picture. There is something called as TTL, not TLD, TTL, time to live, meaning how long your IP address should be cached in in these systems. Okay, meaning after you can set it at as 86,000 seconds, which is 1 day. After that, automatically it will do a new query and get the latest IP address. Okay, that's the time to live. Okay, we can set it on the DNS, right? So all these things are happening only to get your IP address, but we will never realize that our systems never take that long also, particularly for very frequently known websites like google.com or Netflix or WhatsApp. Even of course your mobile apps also, you're not typing web app whatsapp.com, but in the background there is a DNS that is being happening, that's happening. Okay, um, so this happens in microseconds, okay, nanoseconds in fact. And also, since DNS being very distributed in the sense, you have the IP address cached in multiple locations all the time, it's very easy to retrieve it and super fast. Okay, all these things we have done only to get the IP address. So now you get the IP address for google.com. Okay, what is an IP address? IP address is like address for um, a computer. Okay, of course, we'll talk about IP addresses tomorrow. So you got the you got the address. Now you know where to go. So your system will take to, because now your computer know the IP address, it will take to the router. It will take to the particular server. Okay, that's the DNS part. Okay, so before I forget, there is one beautiful video on YouTube. I really like it. You should also go through it. Subtol, how DNS works. DNS works. Yeah, DNS explained. I think this is the one. Yeah, this is the one. So go through this after the class, and this is very well explained with all the, animations and stuff like that. All right. Okay. So now you got the IP address. You go to the web server, but here's the catch. Okay. So let's say Google is a very big organization. It has a lot of money, and it gets millions of requests from World Wide Web, right? From the people around the world. Okay, any questions so far, by the way? Okay, I'll proceed. So let's say you are sending a request to Google, and there is a Google web server which specifically answers requests from browsers or whatever. Okay, so the request is received to the Google server. So let's say, because Google is a very rich company and rich corporation and everything, let's say it has super configuration, like 30 terabyte of RAM and 1024 CPUs. But what if this goes down? This server crashes. What happens? Let's suppose it can answer 10,000 million requests per second, but still it's down. What happens?
There should be an alternative, right? If it goes down, like
Okay, there should be an alternative. So what is that? It could be
like
secondary machine, right?
yeah, other server or something. Yeah.
Yeah, you're right. So there should be an alternative, which is your secondary server. Okay, so let's say there is a secondary server, and let's say its IP address is .20 instead of .10. Okay, these two have, because every computer has its own IP address. Okay, so now what happens if there is a failure in the first system, it got shut down. So now what Google has to do is Google has to redirect the traffic to this server, and it also needs to update this IP address in the registrar, because otherwise all computers are still trying to reach to this server, which is not working, and it will throw errors like 503 or whatever. So what happens when you update the IP address? It again takes a few minutes at least to populate across the all the servers, all the users also. So that means there is a downtime still, meaning there are a lot of people still not being able to access the google.com website. So not a very bright solution, right? So what can we do in this case? Because in DNS, unlike our telephone contacts, unfortunately you can only set one IP address at one time. Okay, so and also this failover process, it's called as failover process. It takes a few minutes, or at least less under a minute also it takes, but you can imagine the the amount of disruptions it can cause. So what can we do at this stage? Okay, so here comes a concept called as load balancing, meaning you have multiple servers running at the same time, or more than one, let's call it as more than one at this time. And this now there will be a device in front of these things, okay, which is going to redirect the traffic from the end users, or distribute the traffic, in other words. Okay, distribute the traffic to these two servers in a whatever way you can set it up. Okay, now this IP address will be actually, okay, the router's IP address, let's suppose, not router, sorry, load balancer's IP address. Okay, so you can think of it as, the load balancer as the opposite of the router. Router takes requests from all the servers and send it as a single one. It receives requests from multiple devices and it distributes to how many ever systems are there in the home, in the service. Okay, so this is fine. So you have a load balancer which receives the request. So what happens is, ideally this is the IP address, you put it in your registrar name, okay, which will actually receive the request from the end users. So a load balancer could be another server. You can put a server also as a load balancer, but these days we have very specialized devices just like our routers, okay, which can take millions of requests per second and distribute the traffic across multiple things. Okay, so load balancer is a what do you call, a network device that can be installed in your data center, and it can take requests and submit. Okay, but think about this, right? When you think about any service like google.com or YouTube, or let's say um, WhatsApp, whatever service, mobile or web-based services also, they have lot of data, lot of files, a lot of other services that are coming in, right? So when you open google.com, for instance, right? So you see, this is what we call as the GUI, or graphical user interface. The um, the logo, the username, the various references to other things. This is what we call as the uh, GUI, or graphical user interface, or the front end, in other words. Okay, so this is what we call as the front end. But look at this, when I just enter something, it already populated some of these things, okay, which is coming from my history, obviously, which might be stored locally on my machine also. It need not be even stored in the Google servers. It is all stored on my laptops, my browser history, or my browser cache. That okay. um, so for example, when I type, okay, how DNS works, you see I already instantly gets the results. Okay, so this might not be the front end server which is answering these responses. Okay, um, there could be a, wait a second, I have too many windows open. Hmm, close this. results here. Okay, so there might be, and also the results also, right, vary from person to person. When I hit enter, it will serve set of results, but what results you get are different from what I get, right? You might have already experienced this. This is because Google has this algorithm which knows my history, my behavior, and what kind of information I mostly look for. Is he a technical guy or not? Google already has all that information about me, unfortunately. Okay, so that means it has to process my profile and give me the results. So there is something called as business logic, or some kind of application logic that's happening. So there are front-end servers or web servers, and then there are your business logic processing servers, which are called as you know app servers. And then there is a place where Google has to store all the data real time, okay, both about the users and also about various other things. So then there is this database layer. Okay, so typically you have this kind of, I mean, it's again old school because it has changed now, but at least you get an idea, right? There's a web front end, there's an app app tier, and the database tier. And in every section, we need at least two machines for what we call as high availability. High availability means your systems are always available to the end users. Even if one of the system is down, for example, let's suppose this system is down, or the networking cable is cut, or the OS has an issue, the system restarted, you still have another system to talk to. And of course, there should be some kind of internal load balancing also, because even computers talk to others' computers only with IP address. So you need to have one central point that will be your load balancer typically. Okay, so this kind of setup, we call it as a three-tier setup. But modern computers have, or modern applications, not computers, sorry, modern applications have more layers than just three layers. Okay, you have something called as a caching layer, which will speed up your you know uh, requests faster, because whatever you get from database, it will be stored in the caching servers. These are only used for caching. Okay, and then you might have something like an analytic real-time analytic service. For example, let's say your amazon.com or flipkart.com, it has to analyze real-time user data and maybe give real-time inputs. Okay, so, and then again, we have different kinds of databases. We have SQL databases, we have NoSQL databases. So we have different tiers. So when this is called as tiering. Okay, each of the application, each of the layer, I mean, we don't call layer, but we call it a tier. So when you have only like web, app, and DB, it's a simple three-tier one. But when you have multiple tiers, it's called as surprise, and tier. And stands for any number greater than 2 or 3 or whatever. Okay. Um, so but today's architecture is little different than this. Okay, we have what we call as a microservices architecture. Okay, that means when you make a request, uh, when you make a request, sorry, what's this from your laptop? After the DNS resolution, of course, after the DNS resolution happens, it goes to a particular, you know, particular server, or it need not be even server. We have what we call as containers these days. Containers are nothing but lightweight. Containers are nothing but lightweight VMs. We can talk about that later, but just giving an example. So the front end is served, or the GUI is served by this one. Then you make a request to login. You click on login button. It might be sent to another kind of a service or another container. Okay. So just for the authentication, you have another service. Then maybe for your app processing, there might be multiple units. Okay, so nowadays, I mean, this is what we call as the older system was known as monolithic approach, where the entire application processing and everything was stored in single piece of code. But now it is spread across small units across different servers or different containers. That's what we call as microservices these days. Okay, I will also try to find nice videos or pictures regarding microservices, and I'll share it with you. So you might have also heard about this microservices architecture everywhere these days, right? Okay. Yeah, you can see, right? Okay, there's an API gateway, it will send an account service, there is an inventory service. So if you open amazon.com today, for instance, okay, everything you run is run in the form of for us it looks like a single interface. That's fine. Okay, but from the from the development side, from the way Amazon maintains it, this this single functionality is a service which is maintained by a separate team. Okay, this single service, like what should happen when you add an item to the cart, what should happen when you check it out, what would happen when you delete it, all this will be maintained by a separate team. Okay, there will be a separate team to just maintain your, let's say, gift card section. Okay, I'm not talking about the business side, I'm talking about the IT development. Okay, so everything is divided into a microservice. It's not all single code put together and running it. Okay, so every single functionality is divided separately and is maintained by separate teams. That's what we call as microservices today. Okay, we'll come to this more when we talk about Kubernetes and other stuff, but just giving you some idea. Okay, so typically old school monolithic services were slightly different. So if you see monolith means a single big stone. Okay, whereas microservice means, yeah, see, everything was set in one single code base. Okay, whereas now everything is split into multiple microservices. Okay, so you might have a different data access layer, you have an UI layer, you have a business, it's what we call as web and app and data layer. But here, you know everything is split into small services. The authentication is taken care by one set of servers or one set of containers. The add to cart is taken care by another set of containers. Okay, so that's how it works. But remember, we hear a lot of terms like containers, okay, serverless, cloud functions. You might have come across these things in your day-to-day life. Cloud functions, okay, or PaaS, okay, web apps or Azure apps, whatever you hear all these things, right? Remember one thing, even if you hear the term serverless or containers or VMs, even VMs, right? So no matter what, at one stage, at the final stage, they all have to run on a physical computer. Okay, a physical computer such as this. Again, I showed it to you in the demo also. Let me show it to you again. So there will be a server like this, which is sitting in a data center. Even if you call it containers, serverless, whatever, it has to run on a piece of metal, particularly silicon processors and all these RAM and everything. Okay, so you need to have some kind of physical machine at the end of the day to run your application. Okay, but for you, or not only for you, even for the people who are writing who are writing the programs, or even the people who are maintaining them, they don't have to worry about what is the physical machine, what is its make and all that, because this is what we call as abstraction. Okay, so you have a physical machine, or what we call as bare metal. Okay, on top of it you have virtualization technologies. I'll briefly talk about virtualization and we can end today. Okay, and again, you don't have to learn virtualization or anything for your DevOps career, but it's important to understand how these things work, because it's important to understand this terminology also. So there is something called as hypervisor. What this hypervisor does is, okay, again, going back to this example, right? I told you, right? If we are talking about Google, just imagine these number of systems into like 2000 or something. But even if you take a small application, if you have to run everything on physical servers, it becomes very difficult. Okay, why? Because it's always recommended to run only one kind of application on a server, on one operating system. So for example, if you don't have an hypervisor, you have a physical machine. or a server. On top of it, you install, let's say, something like Ubuntu. On top of it, you can only run, let's say it's a web server, let's say it's a UI layer. You can run, let's something like Nginx, okay, and you need to create another system as a high availability setup, and then you need two more systems to run your database, and you need two more systems to run your applications. Because one physical server ideally should run only one core service or one core application. Okay, I'm not talking about other services, other small services which run on your computer like networking service and other things. I'm talking about the service which is actually exposed to the end users. Okay, so if you have a single machine and only one software can be installed, or it can serve as only web server, of course, it is technically possible to have your web server, let's say you're using something like Apache software as for your web layer, and for application, let's say you are using something like Tomcat, which is a Java based application, right? Um, and for your, let's say, the database you're using MySQL, you can all, these three are nothing but softwares. Okay, if you take a server and install Apache or Nginx, or in case of Windows based servers, IIS, if you install these things, it becomes a web server. If you install Tomcat or let's say a WebSphere, okay, or running some Python program, it becomes your app server. If you install something like MySQL or SQL Server by Microsoft, or you install Oracle SQL, it becomes a DB server, database server. But technically, you can install all these three things on the same server and run your application also, no worries. But it is not recommended. The reason being, generally what happens is when you install database, the database takes up 90% of the memory by default. Even if it is not using, it will clog up all the, it will hold up all the memory. Okay, so that's one reason you always have to separate DB. Of course, the web and app also can be run on the same system, but it is also again not recommended because of memory leak issues and other things. It's called as decoupling. Okay, so less dependencies. You can manage them separately. You can manage them separately, and you can install updates separately. Okay, um, so if you run everything on physical machines, it becomes very difficult to manage multiple amount of servers. Okay, so just like how DevOps is a buzzword now, around 2000s it was virtualization, VMware. Everyone was talking about VMware, VMware, VMware. Okay, talking about early 2000s. So what this VMware company has, even before VMware there are some products, but VMware made this hypervisors very popular. Meaning you can take a single physical machine like this, okay, and instead of installing the operating system directly on this machine, okay, you can install something known as hypervisor. Let's say this machine comes with, of course, all, you can say, yeah, what happens if we manage only everything through physical machines? You can take a smaller machines, but generally these machines are costly and they come with superior, at least, much greater capability than our regular systems. Maybe it has something like, let's say, 64 GB of RAM and 16 CPUs, 16 cores, okay, or let's say 32 CPUs and little 128 GB of RAM. Okay, so how many CPUs does our computer have generally? How many cores? Okay, not
Nowadays we are using octa-core.
Eight.
yeah, we have octa-core. Yeah, that means you have
Yeah,
a very
eight.
you have a decent computer, right? But mostly if you're using it for home purpose, you might also have quad core, which means only 4 cores,
Four.
right?
Yeah.
For of course, some of our phones also have octa-core. But yeah, mostly 4 cores or octa-core, or if you are rich and if you have a MacBook, maybe 16 cores. Okay, but servers, I'm talking about a single physical machine that might come with anywhere like this configuration. Okay, so just to install this for a web server might be a waste of energy. So then came this concept called as virtualization. Okay, the concept is you install, instead of installing an operating system directly on your physical machine, you install uh, a software which is also like an OS, but it's called as a hypervisor. So this hypervisor, what it lets you do is, so the examples of hypervisor are, we have VMware ESXi, we have Hyper-V from Microsoft, We have Zen and KVM, which are open source ones. Okay. So these kind of tools, I mean, you don't have to install all of these. You can install any one of these tools, okay, on top of your physical machine, okay, and then this will let you create multiple virtual machines, okay, each of them acting like a physical machine. Meaning, let's say you can create this one, and here you install Ubuntu operating system, okay. You can install and create another VM, maybe slightly smaller one. Let's say this has 16 GB of RAM and 4 CPUs. Okay. So this has 8 GB of RAM and 2 CPUs, or maybe it needs more CPUs, maybe 4 CPUs. Okay, this might be running something like Red Hat Enterprise Linux or RHEL. These are all. Ubuntu is also a Linux operating system. RHEL is also. I'll talk about that a little later. Okay, maybe you have slightly bigger laptop for, let's say this is for your Oracle database. Let's say 32 GB and 8 CPUs, and this is also running RHEL, and you can create another one. Of course, the total number of CPUs you can use can only be equivalent to, I mean, these are all called as virtual CPUs because, okay, this could be like a Windows machine, right? So using a single server, you can create multiple operating systems, multiple different machines. These machines can be rebooted separately, independent of each other. For example, you can simply delete this virtual machine without affecting all other machines. Okay, you will free up the capacity for the physical server. These will come back. Okay, this means what this means is, like, let's say you have a big, okay, big flat or a house without any walls. That was your old school, bare metal. But with the invention of walls, what happens? You can classify your I mean, you can divide your house into multiple rooms like kitchen, bedroom, bathroom, living room, storeroom, etc., etc. Okay, so a hypervisor also does the same thing. It gives you the capability to create multiple virtual machines. Each of them acts like a separate, what do you call, independent machine, which can be rebooted independently, which can be updated independently. Okay, for example, you can run RHEL version 9 here and maybe RHEL 8.5 here, right? And you, on top of this, you can install whatever software you want to install. So I would say the one of the predecessors, or the one of the initial steps for cloud is virtualization, because virtualization has become so popular. It has become easy for digital services to go live. It has become easy for us to get jobs because outsourcing and globalization, everything. And also it eventually led to the birth of cloud. Okay, so because cloud is nothing but a giant hypervisor running somewhere, and you can create any number of machines you want to. Okay, yeah, of course. That's why I told you, even if they told you it's a serverless thing, you don't know where the physical server is running, but there is a physical server running for it. And maybe there's a VM also in between. Okay. So then on top of it, we have what we call as containers. I will explain to you containers a little later. Don't worry about that. I mean, if you don't understand, you might have heard about the term Docker, right? So Docker is nothing but a software which helps you create containers. Okay. So then we have containers. All these can happen if you have a physical machine. So cloud doesn't mean everything is in the air. It's totally on the ground. Okay, right? So again, coming back to this topic, in a traditional data center, I mean, forget about cloud or anything. If you manage your applications, you have bunch of physical machines which may be converted into multiple, you know, virtual machines. You have load balancers. You have devices like switches, routers, network cables, and everything. Okay. So if you look at the point I'm trying to say is, if you look at any kind of setup, cloud or on-premise or anything, it's made of three kind of resources at the basic end. It's like, I mean, at the basic level, it's compute, network, and of course storage, because each machine also has some kind of storage within it, but it's not enough to store for a large organizations. You need to maintain bunch of disks separately. Okay, like and you can create a storage area network or a NAS, network attached storage. Anyway, I'll just create disks here. So you'll have a bunch of disks combined together to form one single, storage unit also. So any kind of IT infrastructure has these three things: compute, storage, and network. Compute is typically your physical machines, which can be also run as virtual machines. Network, everything regarding firewalls. What is a firewall? I'll talk about that. Switches, cables, routers, load balancers, right? Everything is part of your storage is typically disks and more disks, okay? And the way you use it. So within this, you can create all your web servers, database servers, whatever you call it, and you can also create containers and serverless and everything. Okay, so yeah, that's how your applications run. So at the end of the day, when you're saying cloud or anything, there is a physical machine somewhere running your I mean, it's taking the request through your network cables and processing it and sending the data back to you by the network cables. Okay, by the way, that leads to an interesting question: how is our internet running? Is it wired or wireless today? World Wide Web,
Why?
wireless or wired?
Why?
We have 5G, right? Everything should be on the air. So even
Wireless.
if you no, everything is wired today. I mean, wireless only to a certain extent. For example, we think we are using mobile data, it is totally wireless. No, it is only wireless till your nearest router, nearest tower. Okay, let's say you're using Airtel 5G connection. It's not totally wireless. It's only wireless till your nearest tower. From the tower onwards, it's only underlying cables. So is our home broadband, right? Broadband is working because there is a cable that is coming to your router. Your wireless connection is only till the router you're sending your request. From there, it's all network cables, and these network cables go across the continents under the ocean. Okay, so internet is mostly running wired only today. We think it's all wireless, but only the end user devices are wireless, meaning our laptops, our mobile phones, everything else is still wired. Okay, yeah, unless we have something like Google is starting Li-Fi or whatever, and there is Starlink by Starlink is another company which is trying to work on the satellite internet. But today, most of our cable is, I mean, most of our internet is wired and under the oceans. Okay, so tomorrow what I'm going to do is I will again revise the three-tier and n-tier structure, and I'll also talk about concepts like firewall and how these things happen in cloud also. Okay, and particularly tomorrow I will have a networking session. So we'll talk about what is a network, what is IP, what is MAC, okay, how do we create networks or virtual networks, because today everything is virtual, subnets and all that stuff. That's tomorrow's class. Any questions? And of course, whatever I've shown you today, we will implement all of these on Azure. I mean, not all of them, at least to some extent. We will create load balancers, we will create virtual machines, okay, and we will also we can also create physical machines, but we don't do that because with our free account, it's not easy to create. Okay, we'll create virtual machines, we'll connect to them, we'll install software, we'll do all that. Okay, we will create load balancers, we will get an IP address through which you can open your website and all. Okay, any questions before we wind up?
So, Kiran, we discussed about microservices, right?
Yeah,
So, can I ask you one question? Like,
yeah,
let's assume if you are like scaling one particular, I mean, upgrading one particular microservice.
okay.
So, how it is possible? Like, can we access other microservices? Like, let's assume like, so we are implementing something in cart in Amazon, like
Yeah, yeah,
Amazon.
yeah.
So, can users access like other sections like products and something else?
Oh, yeah. I mean, that totally depends upon the deployment strategy, and these days it has totally changed. Okay, you will never notice it, it's almost seamless. What do I mean by that,
Okay.
right? What do I mean by that? Let's say you have, let's suppose, let's not even talk about containers. Let's suppose, you know, Amazon is running multiple services, okay?
Yep.
And each of them are running on at least, let's take only 2 virtual machines an example, but they have more than that. If not virtual machines, they're running on containers. Uh, so let's say we have okay, let's say we have 6 service. How many we have? 1 2 3 4 5 6 services. Okay, so we have 6 services, and let's say this is only the this section is where your cart is running. Okay,
Yep.
okay, this one is where your cart service is running. So the way the let's say the version of the software it is running is version 1.7. Okay, because whenever you make new changes, you create a version for that. Let's put 1.7.2. Okay, so let's say there is a small change that has been implemented, and the new software version is version 1.7.3. Now, the way this applies is, okay, both the machines will not be updated at the same time. First, this machine will be updated. Okay, that means during this time, if there is a downtime, all the requests are going to this server, and as soon as this is updated, okay, as soon as this is updated, now once that is updated and ready and connected to your load balancer, the second one will be updated. Okay, that means you have zero downtime. This is one approach, and there is even better approach than this, because cloud and everything is very easy. Now what you do is, you before you make any change, you create a new virtual machine which runs, let's suppose these two are already running 1.7.2. Okay, so you create a new virtual machine which runs 1.7.3. So now remember, there are 2 services always running, I mean 2 VMs already running with the older version now. So now what happens, you create a new VM with the new latest software, and now you bring it as part of your pool meaning the service through which your load balancer is connecting. So now you have 3 machines instead of 2. So now what you do is, you take out uh, one VM, delete it, because it's an older version one. So you still have 2 virtual machines running at this time. So now what do you do is, you create another virtual machine with the latest version again and add it to the pool. Okay, come on, sorry, why can't I copy this? Hey, I hate this. Yeah, you add it to the pool. So you have 3 machines, and 2 of which are running the latest version. So but your primary target is 2 machines. So you remove the, sorry, you remove this one, and only 2 machines are running. I mean, now 2 machines are running with the latest version. So in this phase also, what happens is, some users might still see the old feature or the new feature not being visible. But at no point in time there is a downtime, because there is always an additional machine but not lesser machines, right? So this is one way of deployment, right? There's still another way, right? You have this currently entire set running on one version. You create another version of all these servers, okay, and switch over to this load balancer that is also there. Okay, and today with things like Kubernetes, it's become even more easier to do this. Okay, we are talking about VMs, but when you talk about containers are again like lightweight VMs which can be run on top of VMs. So with Kubernetes, it's always easy to, I mean, I'm talking about only, let's say, each service having 2 layers, or 2 replicas, but you might have even more. So even in this case, what happens when you want to upgrade, 2 machines are upgrading at the same time, but the old ones are still not deleted. Okay, so in this way, you can achieve what do you call zero downtime deployments, meaning you're making a change, but your services are never going down. But the old system, when you have a monolithic system, even if you're changing a simple thing to cart, you have to update the entire code base. That's the difference between microservices and monolithic services. Okay, here the advantage is, you can just make changes to the only the cart part and integrate with the other systems. Okay, make sense?
Makes sense. Yeah. Thank you, Kiran.
Yeah. So there are, I mean, I'll talk about these deployment strategies later, but we have certain deployment strategies like blue-green deployment, okay, which is what I talked about. You will create a new set of everything and load balance, switch your load balancing to that servers, okay. And you have rolling releases, which I talked about in the first step, where one of them is updated, and only once it is updated, the second one will be updated. That's rolling release. We have canary deployments and all that stuff. Don't worry, we'll talk about them. Okay, any other questions? All right, then. I know it's already quite late for you. We'll connect tomorrow and we'll talk about a little bit of networking. See you all tomorrow.
Thank you, Kiran. See you tomorrow.